Topic 2, Day 4, Inverse Functions. So inverse functions, or f of -1, undoes what function f does. For example, if you consider the function f of x equals 2x, 2x is telling you to double the input. And we can undo the action of doubling by applying the function g of x equals 1/2 of x. And 1/2 of x halves the input. So if you have some variable x that goes through function f, gets doubled, goes through function g, gets halved, you end up with the original x value. All right, so that's what inverse functions do. They undo each other. Graphically, if you look at this, we have a function f of x and g of x, marked in that blue and the yellow. And what you'll see is that they reflect across that red line. The red line is y equals x. And what's really cool is they'll always reflect across this y equals x value. Okay. Algebraically, to find the inverse and solve for the inverse, we're going to write y equals, flip all of our x's and y's, solve for y, and then rewrite it as f of -1, or the inverse function of f is equal to whatever you got. You also have to keep in mind that the domain and range of inverse functions flip. So if you have your original function and you have some domain and range, your inverse function, right, the domain is going to be the range and the range will be the domain of your original. So they just flip. You need to keep that in mind. When we look at teacher example number 1, it says to find the inverse of this function, and we have the graph of this function on the side, right? It is a cube root function, which actually means that both the domain and the range is all real numbers, right? Because to the left and to the right is going to continue forever, and then it's also going to slowly but infinitely move up and move down. Okay, so that means for our inverse function, our domain and range will stay all real numbers. Now, when we're solving for the inverse, we're going to rewrite it as y equals negative cube root x plus 5, and then we're going to flip our x and y variables. Okay. And then we can think about using PEMDAS for the order in which we need to solve for our y value. We do have addition and subtraction. We have a plus 5, but the plus 5 is stuck inside of our exponent. So in order to get to that, we have to cube it at some point, right? And until we cube it, we can't do the minus 5. So we're going to move up to multiplication and division. And we have something that's being multiplied, actually. This negative is being multiplied by that cube root. So we're going to divide by 1 to undo it. And then we get negative x is equal to the cube root of y plus 5. Now we just have the cube root, so we can cube all of it, which means we're going to cube all of the negative x. And we're left with y plus 5, so we can subtract 5 from both sides, and then we get y is equal to the quantity of negative x cubed minus 5. And then we just need to rewrite it as, since this is the inverse of our f of x, f of -1 of x is equal to negative x quantity cubed minus 5. Okay. And again, our domain is all real numbers, and our range is all real numbers. Okay. So try student example number 1 on your own. Now, for teacher example number 2, we have this inverse function, f of x equals x minus 1 over x plus 2. Now here, what you'll notice is we have a few asymptotes. So let's take a look at where our asymptotes fall. We have one horizontal asymptote that lies right here. So that's going to be y equals 1. And then there is a vertical asymptote right here, which is going to be at x is equal to -2. So it can never fall on those two asymptotes. So when we think about our domain for this function, it's going to be all real numbers except x cannot equal -2. All right, so any other x value works except for -2. And the reason why we have an asymptote there is if we look at this bottom denominator of our function, if we were to put in a -2 plus 2, right, what we would end up with is a 0 in the denominator, right? And a 0 in the denominator is undefined, right? So since it's undefined, we end up with an asymptote. We cannot have a value where the 0 is in the denominator. We don't comprehend that. Similarly, when we look at the range, we're going to have all real numbers except for where the y is at 1. So y cannot equal 1, okay? So again, the domain and range of our original function is listed here. Once we find the inverse, we know that they're going to switch, right? So the domain here will become the range of our inverse. The range here becomes the domain of our inverse. The steps to finding the inverse are the same. So we're going to start off with rewriting it. Y equals x minus 1 over x plus 2. And then flipping all of our variables. So we get y minus 1 and y plus 2. Now, since we have a fraction here, and I want to get rid of it, I'm going to multiply both sides by y plus 2. So I get x, y plus 2 equals, those cancel out, we get y minus 1. I'm going to distribute xy plus 2y equals, over 2x equals y minus 1. And now since I'm trying to get the y's together, right, and isolated, I'm going to subtract y from both sides. I get x, y minus y plus 2x equals -1. From here, I'm going to get rid of the 2x. So I'm going to subtract 2x to both sides. xy minus y equals -2x minus 1. From here, since I have a y in both of the left-hand terms, I can factor that y out, and I get x minus 1 is equal to -2x minus 1. So once I have that, I can actually divide both sides by x minus 1. And I get y completely isolated. All right, and since I have y by itself, my right-hand side does not have any y's in it. I can rewrite it as f inverse of x equals -2x minus 1 over x minus 1. Okay, where my domain is all real numbers, but x cannot equal 1. And my range is all real numbers, but my y cannot equal -2. All right. Go ahead and try student example number 2 on your own.